Hello, everybody. Good morning or afternoon or evening to all of you, and welcome to Day 2 of Blue Forest Week 2022. Today's webinar is titled Learning from the Meadows, Pathways for Seagrass Conservation and Restoration. Yesterday, if you were with us, we had 4 great presentations about the status of seagrass meadows and threats to them, as well as in-depth discussion about seagrass ecosystem services. Before we move on to today's topic, we have a short video from the ResilienSEA project summarizing seagrass ecosystem services. The ResilienSEA project will actually be the subject of our 3rd presentation today. So today we have 4 talks covering basically case studies of seagrass conservation and restoration from West Africa, Southeast Asia, and Northern Europe. We'll have time for one quick question in between each of the talks, and then we'll have a Q&A session with all the speakers afterwards. This will be followed by a panel discussion, which will close around 10 past 11 Norwegian time, a short closing statement. And then if anyone wants to stay and chat with some of the speakers in a more casual, informal discussion afterwards, some of us will be sticking around. So for those of you who don't know me, I'm Karin Gagno. I'm a researcher here at the Norwegian Institute of Marine Research, and I focus on seagrass ecology. And so our speakers today are all working in seagrass conservation and restoration around the world. And our first talk will take us to the west coast of Sweden, where we'll learn about eelgrass restoration using shoot transplantation. The talk is given by Dr. Eduardo Infantes, who's a researcher at the University of Gothenburg in Sweden, part of the research group ZORRO, which is short for Zostral Restoration, which have been developing new methods for management and conservation of eelgrass habitats. Dr. Infantes will be joined by one of his colleagues, Dr. Per Moksnes, who's also a senior scientist at the University of Gothenburg and part of the ZORRO group. And so they will be available also for questions after their presentation and during the Q&A session and panel later.
Hello, everybody. My name is Eduardo Infantes, and today I'm going to be talking about eelgrass restoration in Sweden. So I'm not working by myself. I'm part of a team of biologists, environmental lawyers, and environmental economists who call ourselves the ZORRO team. And we are looking at the causes of eelgrass losses in Sweden. We're looking at methods for large-scale restoration. Also looking at the legal, ecological, and economical aspects of compensatory restoration. And also looking at the value of the ecosystem services produced by eelgrass. So we have developed national recommendation policies for eelgrass mitigation and compensation here in Sweden. Zostera marina is the main seagrass that we have here, also called eelgrass, and it's mainly found in the southern part of the country and around the Baltic. And it grows in kind of sheltered fjords like these ones, and this is how it looks like. But seagrass has been declining. It has been estimated that around 60% has declined since the 80s, and this is due to overfishing and eutrophication, which has led to the loss of around more than 12,000 hectares. And this is how it looks, eelgrass meadow, when there is some filamentous algae growing on top of it. So since we had all these seagrass decline, we thought about restoration. So we have been testing different methods for restoration using seeds and using transplants. I will tell you first about seeds. So when you collect seeds, basically you pick up the reproductive shoots and you put them in tanks inland, and then when the seeds are mature and they ripe, they can collect them, and then you put them in the field. So we have been testing different methods for seed harvesting, collection, germination, and storage and planting. And our conclusions are that in Sweden it's not very efficient to restore using seeds because of mainly two reasons. One is that there is very low number of seeds available. The densities of reproductive shoots is very low compared to other places, and the germination and the success rate in the field is very low as well. In addition, we need to scuba to collect all this. We cannot use volunteers, so it also increases the cost of doing these activities. Instead, we have seen that planting shoots by transplantation, it has been working a bit better. Basically, it's a bit more reliable, and when we plant, in most places it grows. You can see an example of a patch of 9 shoots that after 1 year was around 200 shoots. And we had success in planting small patches like this one of around 10 by 10 meters, where we planted, and after a few months the densities went very much higher, from 16 shoots to 95 shoots. We also did tests on larger patches of 20 by 20, testing different densities and configurations to assess what is the most economical and efficient way of planting. And most of these patches, they also work well. We have also attempted larger scale planting. So this is like a half-hectare planting, where you can see here four divers and a boat. And so increasing the size of these plantations. So all these methods that we have developed over the last 10 years, they are available in reports, or you can read them. They are in English and also in Swedish. And there's also some videos showing how to select a site, how to harvest and planting seagrass, and also how to monitor after planting. So all this is available online, and you can have a look. But we have also had problems when we try to restore. So in many areas it worked, but in others it has not been working very well. And this is because there are problems, so we call them feedbacks, that are preventing restoration. So I'm going to tell you about one of them, which is sediment resuspension, which is the one we have been working hardest in the last years. And this is an example of a bay that it used to be covered with seagrass, and you can see this polygon in white. Right now there is nothing. You can see like a darker area, but this is algae. This is not seagrass anymore. And during a bit of a wind event, you can see all these turbidity clouds that produced by the sediment resuspending from the bottom. So this is not sand that is coming, or turbidity coming from rivers or any pipe. It's just generated in there. And this is caused by this glacial mat, which is this really fine sediment that before it was covered by the seagrass. But now, since the seagrass is gone, it's on the surface. So any wave action, it will make this mat to resuspend and making the water turbid. So under this kind of continuously cloudy conditions, it's very difficult for the plants to grow. So we wanted to assess how we could break these feedbacks that are preventing eelgrass recovery. So we thought that maybe if adding a bit of sand on top of this mat, it will, and then planting seagrass on this sand cap, it will stabilize the sediment and reduce the resuspension for the plants to grow. But will sand over mat will improve restoration success? That we didn't know, and we wanted to test. So we carry some pilot tests in between 18 2018 to 2020, and we look at the impact of sand on the infauna. So are we doing well, or are we doing bad at adding all that sand? Can this eelgrass survive in this sand cap? I mean, is the sediment good enough for the roots to grow there, and so on? So we choose 4 areas, and we do some small scale planting, where we put about 1 square meter patches of 10 centimeter layers of sand, and we place around 8 tons on all these different locations. And this is how it looks. It's more coarse sand and the plantings, so you can see how it looks. And we saw that there was not a negative impact on the infauna. In fact, it actually increased the number of individuals in the sand, because the sand is more porous, so there is more oxygen moving, so the number of animals it was higher. And also the density, it worked better when there was sand, especially in the Bay of Askeron. And here, so we selected this Bay of Askeron to go a bit further into this sand capping test. So the next step was to see where to locate the sand and how large the area should be. So for that, we developed this hydrodynamic model with a high resolution of 20 by 20 by DHI, and we calculated the wind-driven sedimentary suspension and turbidity, and we also checked that these conditions were similar to the ones we found in the field. So we also carry many field measurements of turbidity and wave and currents. Then we wanted to see which sizes of the patches will have an effect. So we tested different sand cap areas, and we saw that perhaps adding just 1 hectare in the right place, 1 hectare of sand in the right place, it will reduce the turbidity just enough for the plants to grow. So we went in that direction. We also tested if the sand capping was going to be flushed away during any storm. So we test this using the flumes, and where we expose the sand cap to different currents and waves, and we saw that for the conditions in the bay that we were going to be putting the sand, this sand cap will manage to stay under the the worst scenarios. So then we went ahead and we put around 2,000 hectares of sand over 1 hectare in this little bay of Askeron. Well, we didn't, but we hired a company that is engineers that they are used to do this type of jobs. And they put this 10 centimeter layer of sand of around 0 to 8 millimeters. It's mainly sand and gravel. And in summer of 2021, last year, 80,000 shoots of eelgrass were planted between June and July. And then we were monitoring the light and turbidity, hydrodynamics, and so on over some time. And everything survived. We were lucky. And in summer 2022, the amount of seagrass changed from 80,000 shoots that they were planted to around 860,000 shoots. So this is like an increase of 10 times. And as you can see in these pictures, this is what it was individual plantings. They have changed to more like small patches around, and there's now some sea stars and some mussels and so on showing up in the plantings. And having this, it also opens new questions, which I find it quite interesting, which is, since we have the time 0 or time 1, we can look at changes in the biodiversity in the area, or after planting, or the carbon storage, or what is the effect of this wave and canopies into wave damping and coastal erosion, or what is the changes in the microbiome and so on. So it's interesting to have this test ground. So in summary, Eelgrass restoration is possible in Sweden, and methods are available using transplants. We don't recommend seeds in this area, but feedbacks such as resuspension is making restoration challenging in some locations. And when there is these regime shifts, for example, this resuspension, where now there is no seagrass and it keeps getting cloudy, some complementary methods might be needed before seagrass can be planted. For example, this sand capping. But I always say that it's better to conserve the existing meadows instead of thinking about restoration, because restoration is very costly, it's very expensive, it's very difficult, and in some locations it might not work very well. So conservation is best. And this is a picture of where I am. I am based at Christiansberg Marine Station. It looks like this in summer, but now in winter this is how it looks. Thank you very much.
Thank you, Eduardo. That was really interesting to see that large-scale seagrass restoration is becoming a reality. I will ask you a couple of questions. So Eduardo, or Per, one quick question: how quickly after sand capping do you have to plant the eelgrass so that it doesn't wash away?
Yeah, so we put the sand in spring between April and May, and then we plant it afterwards in June, July. But the sand cap, if it is well designed, I mean the sediment size, it should not wash up at all. At least we have not seen any wash up, because it should be able to stand storms, and it should be stand rough weather. So yeah.
Hey, Marike posted a question in the chat, and we'll get to that in the general Q&A. Continuing on eelgrass restoration, now we're going to focus on challenges of seed-based restoration. This talk is given by Dr. Richard Unsworth, who's an associate professor at Swansea University in Wales, and also the founding director of Project Seagrass, which is a charity devoted to advancing the conservation of seagrass by bridging community, research, and action. Project Seagrass has advanced some large-scale seed-based restoration projects and also using citizen science. And today, Richard will talk to us about scientific bottlenecks and challenges to seed-based seagrass restoration, lessons from Wales.
Good morning, and thanks for giving me the opportunity to speak with you today. I'm going to be speaking about the lessons that we've learnt in Wales, and how I see that in the sort of context of challenges and bottlenecks to seed-based seagrass restoration. Well, I think it's a very exciting time to be part of seagrass restoration. I think it's very much coming of age. We've got large projects that have been fundamentally successful in places like the Chesapeake Bay, increasing large projects in the Vardensee, really showcasing what is possible with seagrass restoration, and our knowledge really is improving. And in the UK, only 5 years ago, no one was really doing this work, but there's been a huge growth in interest in seagrass restoration, with projects popping up all around the country. But whilst we have this improving knowledge, you know, it's really critical to think that there are huge gaps in our understanding of how we use seeds to maximize restoration. So although we often see the pictures that are on the left of this screen showing the exciting, wonderful success of projects, we tend to rarely see the picture on the right, which is the bag of seed that's been ripped open by a green crab, and nothing has actually grown. So, you know, we really need to fill those big gaps in our knowledge. Our first bottleneck is that of general low level of seed germination and emergence across many studies around the world. In lab-based sort of studies, it's not uncommon to get seed germination rates of sort of higher than 40%, sometimes as high as 60%. But generally, we're seeing the sort of the 5 to the 10, sometimes 50 and 20% in the field. And whilst we're improving some of our methods, it's not always clear what the mechanism behind that is. And there's lots of factors playing into this in terms of the how we store seeds over the winter, how we treat them in terms of triggering germination, and what the relative trade-offs are of how we treat those seeds over extended periods of time and when we actually plant them. So I think we really need to dig into the mechanistics behind a lot of these processes. The second bottleneck that I wanted to talk about today was the survival of seedlings. And there's a lot of good knowledge of what light a plant needs. Broadly, what conditions a seedling might need when we think about it being grown in the lab. But actually, when we're trying to build things like habitat suitability models for seagrass, we're generally correlating variables of environmental parameters such as wave attenuation with the known population of mature plants. And that's because we don't really know what the conditions are for a seedling to survive. Yes, we understand that there's feedbacks in that system that are influencing that, but the specific window of opportunity for a seedling to survive and actually turn and expand into a seagrass meadow, we don't know enough about. What are the specifics of the current speed that they can survive? What are the specifics of the sediment resuspension that they can deal with? There's so many subtleties there, and in order to use tools like habitat suitability modelling, we need to improve this understanding. In the context of those other bottlenecks, the seedling survival, the seedling emergence, there's a series of biological interactions that we see remain as key challenges. We really don't know enough about how we deal with an overabundance of particular organisms, whether it be green crabs predating on seagrass, whether it be worms, or just an overabundance of marine algae. Those interactions and that knowledge remains a challenge. But something in that space of biological interactions that we think probably has a major role, but is really poorly understood, is the microbiome. A lot of new molecular techniques are meaning that it's more readily possible to sequence the microbiome around seeds, around seedlings, around mature plants. When we've done some studies in West Wales looking at that microbiome over time in an aging plant, what we see is that microbiome changes from a seedling that's a month old to a seedling that's 6 months old to a seedling that's 12, 18 months old. And is it that microbiome at early periods in the time is unique to that early period of growth and is quite vital in that space, particularly in terms of dealing with high sulfide, in terms of extracting nutrients, supplying key elements to the seagrass, or is it that seedling is desperately trying to enhance that microbiome and it struggles, and maybe we need to be finding ways to enhance that microbiome. And but to date, the work in this space is very much just about trying to document what's there rather than really understand how it's been utilised, and therefore how we can improve that to enhance restoration. There is a well-established problem in scientific research, that it's not sexy or exciting to publish the results from experiments that failed. And while as a research group or as an individual scientist, you may well utilize that knowledge to improve your further work, when those big experiments fail, that learning doesn't often reach the wider scientific community. And it's for that reason that people have set up journals such as the Journal of Negative Results, which a colleague of mine, Mike is involved with. And I think these are great initiatives, because when someone in Sweden or Germany or wherever it be fails, it's so great to be able to understand in Wales why their project failed. What was the key outcome, so that we don't actually end up trying to reinvent the wheel and failing ourselves. And I think as a scientific community, we need to be better in this space at sharing those failures. And we all have them, and we've got our fair share, I can tell you that. But we need to be better at sharing that knowledge. Now, a bottleneck that we see in the UK, but may not be as wide a problem in other locations, is the licensing and sustainable supply of propagules. So when we first started our work on seagrass restoration in the UK, there were no other projects operating, and it was very easy for us to collect seeds in a particular location, get a small scale license for them, and bring them back, process them, plant them out, and that was quite effective. But as our projects have both grown in size and others have come into this space, we're now in a situation where actually there are lots of competing interests to take seagrass seeds. And whilst I actually believe that all of that collection is completely sustainable, we don't really have the evidence behind that to support this collection. And as particularly in places where there are ambitions to really scale up seagrass restoration, these problems become increasingly relevant. And the bottleneck here is that we don't really know enough about reproduction in seagrass. We don't know what's leading to some meadows producing millions and millions and millions of seeds per hectare to others producing virtually none. And a broad understanding that across a particular country we've got so many hectares of seagrass, so actually that means we've probably got X billion or trillion seagrass seeds. And what's the effect of taking a particular proportion? But certainly I see this as a knowledge gap it's really important in terms of an applied sense to give confidence to regulators that we can actually collect these seeds at a reasonable scale. Now, the final bottleneck I wanted to talk about is the engagement of stakeholders, because this is not a traditional part of what we've considered to be a key element of seagrass restoration, but it's increasingly being recognised as something that we need to be doing a better job of. And I don't think we have a perfect model for it. But the thing is that increasingly we see that stakeholders can be a key part of a project. They can create an enabling environment for a project. They can be key citizens in that project that facilitate it, help it move forward, and actually can be the long-term custodians of that project. And within Project Seagrass, we've sort of been feeling our way forward in this space and using a lot of the prior experience as a team that we've had in working in various different parts of the world in different sort of environmental management schemes. But I'm not sure we have a golden answer for what is the best way to approach these sort of these interactions. And yes, there's been some great wins that we've had from what were initially tough circumstances, but we need to use these lessons of learning and try and improve so that stakeholders can be a real genuine asset to a seagrass restoration project. And finally, I just really wanted to highlight that, you know, seagrass restoration is it's challenging. There are ups and downs in doing so, but it's pretty cool to be part of this the seagrass restoration story that's coming together both globally and in Europe, and seeing those projects that are coming together. It was really inspiring recently to have the fieldwork company visit our seagrass nursery in West Wales and tell us the story of how their restoration with their funky planting machines is taking this science to a new level. So overall, I think it's exciting times, but we just need to be mindful that there are many knowledge gaps in that. Thank you for listening.
Thank you, Richard. And Richard is here live joining us. We'll have a little bit longer Q&A session right now because Richard has to leave and won't be able to join the panel. Richard, thank you. A really good overview of things to consider, not just for seed-based restoration, but for restoration in general. And I think a lot of what you mentioned will resonate with what a lot of people are doing in conservation and restoration. So my first question to you is, having listened to both you and Eduardo's talks and the challenges of seed versus shoot transplantation, why did your team decide to go for seed transplantation after all?
Well, interesting question. I guess the challenges of regulation in the UK have basically forced us down that route. We're currently trying to get permission to take 600 shoots for a small scale trial on the south coast of England, and every regulatory headache has been put to us. So I'd like to be doing some of the things that Eduardo's trialing, but I just can't see that the regulators are in support of it in the UK. It's just it's a shocking state of affairs, unfortunately. So, yeah, it's not a great biological answer. It's more a logistical, real world one.
Thank you. Eduardo, do you want to also jump in? There was actually a question about this in the Q&A of what are the benefits of using direct transplants and seeds, and what made you choose shoots versus seeds?
Yeah, well, we started using seeds. We were actually very excited about seeds because of the successes in Virginia and Chesapeake. So we wanted to have a go with that. But after several years doing tests and experiments, it didn't really work very well. We realized at first the number of seeds, it was very low compared to Virginia and Chesapeake. So the densities were very low. And also the germination rate, it was also very, very small. So at the end, doing numbers, because when you want to restore, you also really need to make good numbers so it works for the economy. And we saw that, transplanting, it makes more sense. It's shorter time scale, so you pick and plant. So in one season, you can see if your restoration has been successful. When you use seeds, you need to wait 1 full year. So at the end, we are using transplant. It doesn't mean that seeds are not good, but at least here in Sweden, transplants are working better.
So it seems like overall for both of you, the choice of seeds versus shoots comes down to just local regulations and characteristics of the eelgrass meadows. Thanks. Richard, one more question before we move on. I know that citizen science is an important component of Project Seagrass. How have you found that community involvement adds to conservation and restoration? What are also the additional challenges involved in having citizen science?
I think it's just really exciting. You know, we're faced with huge doom and gloom scenarios of a climate emergency, and there's increasing reality that people want to get involved with conservation. People want to do things that make them feel like they're contributing to saving the planet. And you know, we've had hugely diverse groups of people who are coming in and helping our project. And because we're doing seed-based restoration, it's very easy to have pretty non-scientific individuals going out and collecting. It's just like going blackberry picking whilst wading in the water. You know, it's a lovely activity that people can get involved with. And you know, we even had some volunteers involved in the project a couple of weeks ago, where we were looking at the nutrients present in the seagrass to look at potential future sites of restoration. And we had volunteers scraping and cleaning and grinding seagrass. And actually, if they understand that they're doing a job that's got an important role, then they're more than happy to get involved. And it's an asset, absolutely. Okay, there's always going to be moments when it's a bit of a headache with, you know, different groups. But overall, on balance, it's a major positive to the project.
Great, thank you very much. We're going to move on to our third presentation, and now we're moving to the Gambia and the ResilienSEA project. This presentation is by Omar Sanneh, who's the head of Research and Development Unit of the Department of Parks and Wildlife Management in the Gambia. Omar is the focal point of the ResilienSEA project in the Gambia, where he leads seagrass education and conservation efforts. And through the support of the UNEP ICRI small grants, he's also currently implementing the region's first ever community-led seagrass restoration program. And he will tell us more about that in his presentation.
Good evening, everyone. My name is Mr. Omar Sanneh, Head of Research and Development Unit, Department of Parks and Wildlife Management, under Ministry of Environment, Climate Change and Natural Resources, the Gambia, West Africa. I am also the national focal point of the ResilienSEA project, as well as the coordinator of the Banyamo Tanko project. I am here to do a presentation on the conservation of seagrasses in West Africa. The title of my presentation is The Dawn of the Seagrass Conservation in West Africa, ResilienSEA and Banyamo Tanko project. So the presentation outline is here. You can see the presentation outline before you, and then the official seagrass conservation started in West Africa back in 2018 under the ResilienSEA project funded by the MAVA Foundation. The project basically was focused on four strategies. Strategy 1, capacity building, scientific research. Strategy 2, capacity building. Strategy 3, information, communication, advocacy, and awareness. Strategy 4, on policy development. These were the four strategies. So during the implementation of this ResilienSEA project, which is a sub-regional project, 7 West African countries were selected to be part of the project, which include the Gambia, Senegal, Guinea-Conakry, Guinea-Bissau, Mauritania, Sierra Leone, and Cape Verde. These were the countries. And in each of these countries, various national stakeholders were brought together to form what is called National Implementation Team. The National Implementation Team, in short NITs, were responsible for the implementation of the activities of the ResilienSEA project at their national level. So in the Gambia, the National Implementation Team were able to discover 3 seagrass pilot sites, the Gunjuru, Bijol Island, Gunjuru, and Katong. And of course, we were able to record the 2 species of the seagrass, that is Halodil and Simodosia, in these various sites. But I have to say that in West Africa, only 3 species of seagrasses can possibly exist here. In addition to Halodil and Simodosia, the 3rd species that can possibly exist is the Zostera nolti. So in the implementation of this ResilienSEA, we have registered a tremendous successes, which I will highlight it later in the presentation. And then one of the big success was that it paved the way for the NITs to go further step, to enhance the conservation of the seagrasses in West Africa. So that is exactly what the national implementation team of the Gambia capitalized on. When there was a call for when there was a UNEP call for a small grant under the International Coral Reef Initiative, the national implementation team of the Gambia, led by myself, Omar Sanneh, and then in partnership with the Alma Charity Foundation and the University of Eduardo Infantes, we applied for this call, and then we were able to be lucky to be one of the beneficiaries of this small grant. So this small grant, we kickstarted the first ever seagrass restoration activity in West Africa, which we call Banyamu Tanko Project. Banyamu Tanko is a Mandinka word, which means conserving the seagrasses. So it is the first ever community-led. So we started this project like that. So the project primarily focused on the restoring the seagrasses bed to the lost seagrasses area, the degraded seagrasses area, is to restore that, and through the community participation, and then also to enhance the ecosystem services of the seagrasses, to improve the fish biodiversity, to improve the carbon sequestration, to improve the coastal protection, and then also to integrate the seagrasses conservation into our national laws and policies, and also to act as a demonstration so that it will be showcasing community-led seagrass conservation and influence the national decision makers to integrate the seagrass conservation at their various national laws and policies. So the activities were to redesign and implement a seagrass restoration. In the Gambia here, we have conducted a planting. So before the planting, we did a technical training workshop, and that technical training program build the capacity of the various participants which were part of the training. So and then that team was used to do a seagrasses restoration in the Gambia. So another chief activity of the Banyamu Tanko is to hold a training capacity, to do a training workshop, like I said, and also to create a management network. Like in the Gambia here, various stakeholders, the government stakeholders, which are stakeholders in the marine and coastal areas, in the coastal and marine environment, were brought together, and then to form what is known as the Seagrass Steering Committee. So this Seagrass Steering Committee, their primary objective is to have a participatory approach, to have a holistic approach towards the conservation and protection of the seagrasses in the Gambia and the region at large. So, and also another activity is to develop a communication strategy. The communication strategy was also developed. This sharp as a tool that will be able to guide us in how to go about our communication communication practice in the Gambia. So the key results that we were able to register in the implementation of the seagrass conservation programs in West Africa, one is the scientific monitoring of the seagrasses bed. Before the ResilienSEA, there was no official record of the seagrasses in the West Africa. But for now, all these 7 West African countries now, they all have a full distribution map of the seagrasses. Particularly the Gambia, we have a full distribution map of the seagrasses, and also the scientific monitoring also enable us to have a data on the seagrasses. Not only the data on the seagrasses, and these data now, we have a regional databases where each of the countries, the data you generated is sent to that database, so that database will serve as a regional database for the seagrasses in the region. So another achievement is the capacity building. We have conducted a series of capacity building, both under the ResilienSEA project and Banyamo Tanko project. So in the ResilienSEA project, we conducted a capacity building to enable to reach to many people as possible as we can. So, but in the Banyamo Tanko project, we did a technical capacity building, technical training workshop. This technical training workshop to equip our national stakeholders so as they will be able to do a seagrass restoration program. So these training workshops were also replicated for university students and the college students, so that the college and the university student will also have the technical know-how on how to do a seagrass restoration. In fact, I can gladly tell you that right now we have 3 students from the University of the Gambia who are currently writing their BSc thesis on the seagrasses in the Gambia. So another achievement we have in the seagrass conservation is the awareness raising. We were able to conduct a series of outreach program, both at the local radio station, community radios, national televisions, and even the community outreach to go to the community to do a community sensitization. We did that. We produced a series of communication material, the t-shirt, the cap, the banners, all this to enable us to reach out as many as people so that the people can be aware of it. So the biggest of all this achievement is the introduction of the seagrass restoration in West Africa. It was the biggest achievement in seagrass conservation in Africa, so in West Africa. So this achievement was very tremendous, was a milestone, was a breakthrough that the national implementation team of the Gambia was able to kickstart the first ever community-led seagrass restoration program in West Africa. Okay, so the prior to this seagrass restoration in the West area in the Gambia, we have only 9 hectares of seagrasses. But after after the successful implementation of this program, we now have 81.3 hectares of the seagrass, from 9 to 81.3 hectares, which is a very huge achievement. Of course, we have some challenges. These challenges include the coastal erosion, eutrophication. Okay, so the coastal erosion is from both sea level rise and as well as the runoff from the community during the rainy season, which is affecting our seagrass bed, because the runoff usually comes with the silt, the sand particle from the coastline, and deposit them on the seagrasses bed, a phenomenon we call siltation. That siltation causes the burial of the seagrasses. So, and then of course the eutrophication also is another condition that is affecting our seagrasses, because the nutrient that is brought along by the runoff is accumulated, and then it results into what we call the algal bloom. So that algal bloom, the algae will compete with the seagrass for the available biological oxygen, and also that it will create an unhealthy competition between the seagrasses and the algae that can have a negative impact on it. So fishing also is another impact. So the fishing is a indirect impact, because the fishermen does not do the fishing directly on the seagrasses, because our seagrasses are surrounded by the rocks. So therefore, because of the proximity of the fish landing site and the seagrasses bed, so there is a tendency that it may have an impact on the seagrass bed. So this is why when we are doing any activity, especially if it is a training activity or capacity building activity, we make sure that we engage the fishermen. In fact, in most of our activities, the fishermen and the local community constitutes the half of the participants. So that they can have a sense of ownership and a sense of partnership in the project activity. So pollution and is also another challenges that we are facing. So for the sake of the time, I'll conclude by saying that a diverse network of actors is functional and need to continue the growing in order to promote the ownership and multiple threats like the pollution, physical disturbance, fishing, and coastal erosion, and so on. Those are some of the challenges that we are facing. And of course, if we have a sustainable financing that will be able to sustainable financing and continued fundraising, that will be very important for us to be able to upscale and replicate this seagrass restoration in program in other part of the Gambia and the other part of the West Africa as a whole. So I thank you all for your kind attention. And I am sorry if there is a noise on the background. I am on transit in Paris right now, returning to Banjul. So if you have any questions, you can ask your question during the webinar. I will be available to answer your question. Thank you.
Hi, Omar.
Hello, can you hear me?
Yes. Hello. Now we hear you.
Yes,
Great.
I am saying I can hear you because we are experiencing a very horrible network, for the couple of months now.
Yeah, that's fine. Join as much as you can. Can you answer one quick question? You have a pilot project, so I assume the plan is to have more projects in the future in the Gambia and in other West African countries. Are there plans for those in place already?
Yes, the main objective is just to kickstart this project in the Gambia here, and when it is successful, we can replicate it and upscale it into the other parts of the pilot site in the Gambia and even other countries in West Africa.
Great. We look forward to a lot more projects. We will get back to you in the Q&A. We'll move on to our next presentation. And now we're moving on to Singapore. Our last presentation is titled Seagrass Connectivity and Conservation in Southeast Asia, given by Dr. Siti Maryam Yaakub, who is a marine ecologist at the DHI Group. And she works across tropical marine habitats, including mangroves, corals, and seagrasses. And her work and research interests lie broadly in ecological restoration, impact assessments, and environmental planning and management. And her recent work has been focused on nature-based solutions for climate adaptation and mitigation in coastal marine systems.
Good morning, everybody, and thanks for having me. My name is Dr. Siti Maryam Yaakub, and today I will be presenting on seagrass connectivity and some of the experiences we had in applying science-based approaches to the management of seagrass around Southeast Asia. So to start, let's talk about connectivity in marine systems. So marine systems are considered highly connected because of the medium of water. And generally, when we speak about connectivity, we refer to three elements. So the physical connectivity of marine habitats, that they have to each other that's driven physically by hydrodynamics. So that's things like waves, currents, tidal cycles, but also ecological or ecosystem connectivity, which refers to the relationships or influence of adjacent habitats and that they have on each other with respect to things like nutrient exchange, the movement of fauna or the migration of fauna between these ecosystems, and etc. And then lastly, we also want to consider within habitat types, so for example, seagrass meadows, how these meadows at different locations are actually interacting with one another. So let's put these three types of connectivity in the context of management and conservation of marine habitats. The first aspect is relatively straightforward because hydrodynamics and hydrology dictates how runoff and inputs into coastal and marine areas are dispersed or transported by hydrodynamics. So for example, managing a nutrient outfall to ensure that there are minimal impacts on adjacent coral reefs or seagrass meadows is very much dependent on things like discharge rates, dispersion, water exchange, and all of these things are driven by hydrodynamics. The second component is this physical and biogeochemical and ecological connectivity, really, because things like mangroves and seagrass habitats act as a buffer for coral reefs by absorbing nutrients and allowing for sediment deposition of river discharge, for example. But it also relates to things like positive feedback loops that these systems exert on each other, such as biological connectivity, like how seagrass meadows act as a nursery for juvenile reef fish, such as rabbitfish and butterfly fish. And this connectivity between habitats is an important factor to consider in both management and conservation. Another example of this is in the area of blue carbon, where allochthonous carbon, or carbon originating from outside the system, can account for up to 2/3 of total soil organic carbon. So if you're looking at mangroves, for example, 2/3 of that carbon is allochthonous, meaning it's originating from other ecosystems or other habitats that are adjacent to that mangrove area. And you can see how the practice of marine protected areas, or MPAs, have also evolved from simply focusing on one habitat to protecting a diverse group of connected habitats in order to increase or buffer overall resilience. And then, of course, lastly, the sourcing dynamics between habitats is also very important when you are planning an MPA, because it's important to know which, habitats are your sources. So meaning they are where a lot of new recruits are originating from, and how this factors in when you are planning a network of sites in a marine protected area. So connectivity is also an important component in the implementation of nature-based solutions. For those of you who may have been living under a rock and have not heard of this concept, nature-based solutions are actions to protect, sustainably manage, and restore ecosystems in order to address societal challenges to the benefit of human well-being as well as biodiversity. So it's kind of a buzzword right now, and if we look at the next slide, we can see that there are various NBS approaches that can be taken to address the challenges humans are facing with respect to the climate crisis and environmental degradation. So if you look at the different types of challenges as well as the NBS approaches, we can see that this theme of connectivity is a thread that runs through a lot of these approaches. So ecological restoration, for example, or ecosystem-based mitigation, climate adaptation, green infrastructure, especially things like integrated coastal zone management, which in itself implies that there is connectivity being considered in that integrated management, as well as area-based conservation approaches. So let's explore a theoretical situation where connectivity plays a big role in affecting the outcomes of conservation and management planning. So in a lot of places in the world, and especially in Southeast Asia, many countries share sea borders or common maritime spaces. And in this scenario, it's very important to remember that nature knows no boundaries, and therefore cross-boundary impacts are a real implication or a real problem. So in this simplified example, we can see that on one side, so in country A, we have them carrying out best practices in conservation and management of their coastal and marine systems. And on the other side, we have country B that is, indulging in unchecked agricultural runoff, sewage and industrial outfalls, unchecked coastal development and land conversion, for example. And this actually has, obviously, as you can see in this example, an effect on the neighboring country. So again, nature knows no boundaries, so let's remove that border. And what we have when we have things like, outfalls and runoff is that it affects not just the marine resources in country B, but because of the transboundary impacts, it actually affects the marine resources in country A as well. So even though you may be doing things in best practice at the national level, what your neighbor does is also just as important. But if in this theoretical scenario, we have both countries agreeing and cooperating to take ecosystem or nature-based approaches to the management of their shared or common or adjacent marine resources and view it from a connectivity standpoint, both sides could stand to gain from this cooperation. So things country B could be doing include things like sewage treatment facilities, having more environmental regulation, having EIAs or environmental impact assessment for when they do coastal developments, as well as ecosystem remediation and restoration. And the reversal of that could then slowly bring benefits not just to country B, which is implementing all of these measures, but also have positive cross-boundary impacts in this case for country A, because the resources there, because of the removal of all these stressors, are allowed to recover. So we're now looking at some studies and examples of science-based approaches that incorporate ecosystem connectivity in the management and conservation of seagrass. So this is some work that I did with my PhD student, or my former PhD student, Samantha Lai. And we actually used agent-based modeling to look at the dispersal of seagrass within the Singapore Straits. And as you can see, seagrass from the small area of Labrador Nature Reserve, those of you who have been to the last seagrass conference and have been to the site know that it's actually a very small site, but even that small site actually contributes a lot of propagules to other places within Singapore and also outside of Singapore. So building on those agent-based models, what you can then do is actually eco-engineer your coastline to facilitate the natural recruitment of seagrass. This is kind of like a post hoc approach, because these areas that are mentioned in this slide over here are actually already reclaimed, but they were reclaimed in a way that serendipitously allowed for the recruitment of seagrass, because in engineering the coastlines to have things like this, for example, this submerged rock bund, which then created these shallow sheltered coastal areas. And in this example, there was a crenulate bay, which allowed for the retention of seagrass fragments in this area, creating these depositional soft sediment areas that amplifies local hydrodynamics, actually facilitates the natural recruitment of seagrass. And we see that over time, so most of these areas were actually reclaimed in the 60s or the 70s, but currently today there are big seagrass meadows in this area because of the dispersal and the connectivity of these areas to source meadows. So as a last example, connectivity modeling can also be used to inform on site selection for seagrass relocation. So this example comes from Brunei Darussalam, where we use hydrodynamics to understand where seagrass relocation should take place. So in this example, we had to relocate seagrass from this island over here to this island over here to get it out of the way of some coastal development. And the survey showed that there were intertidal seagrass in the recipient site at Pulau Bedukang, but then the distribution was patchy. In ABM, agent-based models actually gave an indication of the source-sink relationship, so we know they are connected. And so the site selection boiled down to choosing sites that were most similar to the donor meadow. But this is one example where you can use hydrodynamics to actually inform on site selection, or rather on the process of site selection. So you can see here in this example that seagrass growth has actually expanded beyond the original monitoring quadrat over a period of 20 months. And this is a very sensitive seagrass species. It's extremely small. So the fact that it managed to establish and grow out of the original monitoring plot is a sign of success. So just a very quick plug here to say that all of these numerical modeling approaches to understanding hydrodynamics and how that affects ecological connectivity have been done in the Mike DHI software suite. And that if you are interested in collaborating with us, please do reach out, and I'm happy to take any questions if there is time. Thank you.
Thank you, Siti. And Siti is joining us today. Yes, hello.
Hi.
It's great to have you with us. And thank you for a really interesting presentation. I'm really glad you brought up connectivity because it's so important. And it's something I want to bring up again in the panel discussion. Before we move on, One quick question about these accidental seagrass establishment and accidental seagrass restoration.
Sure.
So what is the balance between seagrass loss and these new seagrass meadows that have been formed by eco-engineering? Can it be considered as a tool for remediation or compensation?
I think, okay, first of all, you need to read Yaakub et al. 2014, I think. Because in there, I actually looked at how much space has been reclaimed in Singapore and how many of those are seagrass meadows, and also then like how many of these accidental meadows have been created. And I say accidental because it's not purposeful, creating these shorelines to kind of like harness the hydrodynamics. What they do is actually to create these shorelines in order to reduce erosion, which happens to be, the right conditions for seagrass growth. So in Singapore, that's what's been happening. But I think, with the realization that you can actually have both, so both, reducing shoreline erosion as well as encouraging or facilitating the recruitment of seagrass into these like new areas. I think there has been a push towards better ecological engineering to kind of harness and to get the benefits of both. So that's kind of like the direction that a lot of the development works has been doing at the moment, or rather like the direction in which it's going. And I guess, what we need to do in such an urban marine environment, and I say urban because there's a lot of urban structures on the seabed and in the sea and around Singapore, and also actually if you look at it around Southeast Asia, because it's a rapidly expanding area. And EIAs, although conducted, may not always be the most robust, right? Or rather, the enforcement and implementation in the construction phase may not be robust across the region. So if we have these sort of tools to help us manage that balance between conserving natural habitats as well as development, then that puts us in, a better way for going forward in terms of conserving these areas. But so far, to answer your direct question, I don't think it's been on par. Mostly because it's not planned to be that way. But I think with some purposeful actions and planning, it could be a means of compensation. But of course, the issue is that then you kind of run out of reclamation space, and to create these sorts of soft sediment habitats is actually very expensive when you look at the construction cost of it, right? Because you, instead of just building a seawall, you actually need space for nature to kind of recolonize and retreat into, which is the problem that a lot of urban areas are facing actually. With things like habitat retreat in the face of climate change. So that's something that we need to consider as well.
Great, thanks. Can all of the speakers and panelists now put their videos on? Maybe keep yourselves muted. Well, we can start now. So I think for the next few minutes, we just take some time to answer some general Q&As that came up in the there's Omar in the Q&A panel. I saw a lot of questions about site selection, and this can be addressed to all of you. There was, for example, a question about do we have an idea of the restoration potential for seagrasses and knowing where to plant without destroying other habitats. There's also a question of what is the current best practice to decide where to plant or sow seagrass. And there's a question actually that Eduardo asked for the Siti's talk about the type of hydrodynamic parameters that you assess when selecting a site for restoration. So maybe we can go through and you can each give a little bit of detail of how you select a site. But sorry, before we do that, I'm just going to introduce our two additional panelists because I didn't introduce them earlier. So in addition to our speakers, we have two Norwegian panelists joining us. Peter Haugan, hi Peter, is the program director here at IMR, the Norwegian Institute of Marine Research, and a professor of oceanography at the University of Bergen. And Peter has many broad interests, including bridging the gap between ocean science and policy, and we think he'll provide some hopefully very valuable perspective in this panel. And our other panelist is Dr. Eli Rinde, who's a senior researcher at NIVA, the Norwegian Institute for Water Research. And seagrass restoration is actually a very new field here in Norway. And we want to learn from others to set up more restoration projects in Norway. And Eli has been working on pilot studies of eelgrass restoration in the Oslo Fjord, and also has many years of experience working on different blue forest habitats, not just seagrass, including everything from mapping experiments on human impacts and interspecies interactions. So welcome to both of you as well. And we'll start with this quick talk on how you decide on site selection for where you transplant the seagrass, as well as how you decide on your donor sites. And Eduardo, this is especially relevant for you. Someone asked, how do you make sure that you're harvesting 80,000 shoots isn't damaging your donor site? So can you talk to us about how you select both your restoration and donor sites?
Okay, I will start with how we select the sites first. And site selection is key. If you don't plant in the right locations, plants are just not going to grow. So it's really, really important to select good sites. And the way we select them is we first look at where it used to be the seagrass before. I mean, places where it has died or it has disappeared, and we use those as our planting sites, or at least where we test. And you can also, when you are selecting a site, you can measure a huge range of parameters from sediment, turbidity, nutrients, and so on. But we came up with the idea to do some test planting. So yeah, you can measure lots of things, but if you just plant some seagrass, like in small patches of 1 square meter, and you can see if the plants are growing. If they grow, that means that, yeah, maybe it's still a good site. You can also measure light and so on, but it also depends on the budget. But just a simple test planting to see like if today the plants can grow, that's good. And in addition, yeah, for the donor sites, we try to look for places that are close to your restoration site for several reasons, because maybe they are genetically or they are more similar to the plants where you are going to restore. So the distance is important, and also because economically it makes more sense to transport the plants short distances than maybe hundreds of kilometers. So the closest it is, the easiest, and yeah, it will make sense for the budget. We have done some tests to look at the impact on collecting those plants from the donor sites, and we haven't seen a significant effect so far. So yeah, it's important to monitor your restoration, but also your donor site to make sure that you have not messed up your site trying to fix another problem. So yeah, yeah.
Thanks. Siti, do you want to talk about a little bit about hydrodynamic parameters?
Sure. So I think, well, my experience is mostly governed by, I don't want to say the real world, but real project constraints, in that, you know, when we do these, it's usually in, you know, response to like a need, right, from an EIA, for example, or an environmental impact assessment that says that there needs to be some kind of compensation for the amount of seagrass loss, like, for example, the Brunei case that we brought up. So in those cases, it's really boils down to what data you have at hand. Fortunately for us, in the places that we work in, we have like relatively good and well-calibrated hydrodynamic models. Sorry, I'm losing my voice. I'm just recovering from a sore throat. So we have these like good calibrated hydrodynamic models, and from there we can actually extract hydrodynamic parameters like currents, waves, you know, if there's going to be any wind, because a lot of the time in this region, intertidal seagrass meadows are quite prevalent, bed shear stress. So those sorts of parameters can first be derived. So of course, we're looking for those shallow, calm, sheltered sites. What we would like to do, I think, is to actually create some kind of threshold for different types of seagrass species so that that can be used as a criteria to inform on, where, which species should be planted and where. And Eduardo, if you want to work together on that, I think that would be a really cool thing to do. But I think like the other constraint we have is that we kind of, a lot of the time clients and governments are really asking for all these like quick fixes, right? So they're like, oh, tell me what's the criteria. It has to be quick. It has to be inexpensive. It basically has to be a unicorn is what they're asking for. So in that sense, a lot of the time, we kind of have to look at the donor side again and try to figure out what are the conditions there and whether it can be replicated at the site, and then use our models to kind of inform on the hydrodynamics and how that might pan out for whatever you're trying to transplant. So yeah, but I would really like to so yes, a lot of the time it's a case by case basis, but what I would really like to do is really come up with a set of criteria that we can use across the region, and maybe even for all kinds of seagrass meadows, on how and where to plant and which species and actually which methods, because I think that is really a big factor as well. Because I understand that when you guys are working predominantly with Zostera marina, there is the option to have like seeds, right? But that's not really an option for tropical species. So a lot of the time you're either planting sprigs or you're planting, like what we did in Brunei was we just took a whole plug, like a core, and then we transplanted those cores. So then of course there's a lot of costs related to that because you have to transport 1,000 cores from one site to the other, and that does add up. So it's kind of like that balance between what's the project budget, what's the timeline. They don't always, timelines don't follow seasonal timelines. So actually, when we did the transplantation for Halophila beccarii, it was actually at probably the worst time to harvest seagrass, which is when their biomass was very, very low. But the project had to go ahead, and we couldn't say, please halt this multi-million-dollar project so that we can wait for the seagrasses to grow back before transplanting it. So yeah, those are some of the situations that we kind of have to circumnavigate in order to carry out some of this work.
Thanks. Eli and Omar, you are basically leading the first pilot projects in your respective countries. How have you decided what are the first sites? How do you select the very first site in your country? I don't know if Omar is still here, but Eli, you can start. And if Omar is here, he can join.
I have to take this down. Yeah, thank you. Thanks a lot for our very nice presentations. As you mentioned, in Norway, this is a very new topic or action. We have not done it before. And in the Oslo fjord, we were asked by the Oslo municipality and they wanted to test if we could be able to restore some seagrass beds. And we didn't know about any seagrass beds in the Oslo municipality from earlier, but based on terrain models and also depth, considering the depth and also substrate types, we assumed that some areas would maybe they have had seagrass earlier, and especially in some of the areas that has now is dominated by small boat harbors, for example. That is a typical area where we suppose we would have had seagrass beds earlier. So we selected some sites based on where we know it could probably the habitat is suitable. Yeah. So, and also in the earlier, we also try to select restoration sites in the EU project MERSES earlier. And that was also difficult because we don't know about maybe a few seagrass beds that has been lost, but since we didn't do any mapping of seagrass beds before 2007, we don't know about lost seagrass beds. So, and we really struggled to find suitable areas where you didn't have seagrass beds for test planting. So I suppose we are very lucky so far that we have not lost, as we know of, a lot of seagrass beds, but we see these increasing threats with turf algae. So I think that's maybe the most important, is to avoid degrading already existing seagrass beds and also avoid future loss due to eutrophication and overfishing.
If we can move on to maybe a more philosophical question. Someone pointed out in the Q&A and specifically highlighted one of Eduardo's points: it's better to avoid degradation than trying to restore afterwards. And I think we all know this. And I was listening to a webinar by Richard, who had to leave recently, and he said governments and managers and companies, they like to fund restoration because it's essentially building something. And it's much harder to convince decision makers to either reduce threats to seagrass or to protect existing seagrass meadows. And I hope Peter can join us in this discussion, because it would be good to hear from a policy perspective as well. So I guess my question is for all of you: how do you think we can address this and basically convince people that we don't only need to restore, we need to conserve so that we don't have to restore? Because ideally we would rather not restore. Per, do you want to start, since you haven't talked so much yet?
Yes, thank you. I think this is a great question, and it's something that we work with a lot in Sweden, because it's so obvious, I think, to biologists that protecting what is, it's so much better in all respects. Because when you lose a meadow, we have seen that in Sweden, it might not be possible to restore that site because of this regime shift that Eduardo was talking about. And it's very expensive. It's difficult, it's risky, and if you had a lot of, let's say, carbon and nutrients stored in the sediment under this living old meadow for maybe being there for hundreds of years, that is all lost and dispersed. So you lost that sort of bank of stuff that the ecosystem services. And I think that is the type of arguments when people tell us, let's put all the energy, like the EU initiative now about restoration. That is all good, but we need to start with stopping the degradation and losses. There's no point of restoring until we fix the environment. And I really like the idea of Siti or the results, that maybe it's enough to just fix the environment, and maybe eelgrass and other species of seagrass can come back naturally. And I wanted to squeeze in a little question to Siti, because I wonder what are the time scale of natural recolonization, because people are suggesting that, but if you read the literature for eelgrass, it's considered to be rather slow. Vegetative growth is extremely slow, and seeds are supposed not to disperse very far, at least not that many. So because that's related to, can we count on natural recolonization, which will be the best option? Thanks.
Thanks for that question, Per. So I think, well, okay, if you look at when those areas were reclaimed, I think it was in the late 60s and early 70s. And the first signs of, like, I guess these meadows like being noticeable was actually when I started noticing them was in the early 2000s. So it's a long period of time, and like you said, like it's very difficult to convince governments, especially governments that change, like, say, every 5 to how many ever other years, to kind of like invest in that sort of like long-term strategy. So what we usually suggest now, knowing that hydrodynamics can facilitate this sort of recruitment, is to then also like give it a little boost at the start. So once you have the area then to like do a bit of like, you know, not a large scale transplantation, but like a smaller scale transplantation just to get a population going there. And then hopefully then there will be a combination of self-recruitment as well as recruitment from other sites. And that's where, like, I guess the agent-based model really comes in, because that can inform you whether or not, you know, whether or not the sites you are building in order to facilitate recruitment actually have recruits coming to them. So it's kind of like a combination of like, where is the seagrass going, and whether that particular, I guess, ecological engineering or building the coastline to facilitate the recruitment actually works. So it has to be an overlap of those two things. But to answer your original question, the time scale I would imagine is quite long. I would say it would be decades, if not more.
I'm going to call on Peter if he can join us and give maybe a more policy perspective on how do we promote conservation and reducing threats to avoid degradation.
Thank you, Karin, and thank you for having me. It's been quite interesting to listen to the talks earlier on. Well, I don't have a panacea, a big solution to this, but I think some of it is psychology, right? You touched upon it. It's easier to sort of get a nice picture of yourself if you fund or go into something which is showing as a restoration. And I guess the problem with the degradation that is happening is that it's typically a result of many different factors. And those factors come from different sources, and some of them are decided on a local basis in the municipality or in the county or something, and those who decide on the various threats are not sort of rewarded for the services that are provided by a well-functioning ocean ecosystem or seagrass ecosystem. So this is, I think, this is part of a really difficult question in terms of how do we do decision making, and how do we do democracy, even local democracy versus national and even global. And I think one possible way out of this is we're seeing now the last couple of years quite improvement in ocean accounting and valuation of ocean ecosystems, not only the services but the natural capital. And there are on the UN level there are some new standards for this which are coming up, and I think that's a promising tool that people need to begin to use more actively. And then we still have to face this thing about you like to make the local community decide for themselves. They may want to have a small boat. They don't want to, take away their sewage or whatever comes out. That is a crucial problem, and something we just have to discuss it's not necessarily a ocean science or seagrass science question. It's more like a democracy thing in terms of dealing with the global threats, which is actually, because this is contributing to global threats, but now I'm sort of opening up another tangent here, but I think there are some key issues here with the scale of decision making. Yeah.
My next point that I was going to give up was how do we move, related to what Peter said, was how do we move beyond these small scale local projects into broader national or even international projects? Like Siti said, nature doesn't listen to our international borders. Any experiences or thoughts to share? Just anyone can jump in.
I think in Norway, at least, we have to maybe modify the regulations, the laws and regulations, because we have not done anything like this before. So as it is now, I think we have to apply for the aquaculture law or act to be able to do transplanting of these seagrass beds, as we became aware of in the Oslofjord test pilot. So it's it is a lot of laws involved in Norway. It seems that maybe if you can develop some or set aside restoration areas, probably. So that could be I think it is in the nature, what do you call it? Natural Diversity Act. But it's still I don't think all these rules and laws and how they apply together, it's needed to be handled.
I think Richard mentioned the same thing about using seeds versus shoots, that they couldn't use shoots because of regulatory reasons in the UK. So it looks like there's a lot of difference between different countries and how restoration is within the context of different laws and transplantation.
Yeah. And especially if you're going to do a large scale, you have to have a lot of, as we did this method that Eduardo and Per-Olav have used in Sweden by transplanting shoots, and that seems, hopefully it works, but if you are going to do this large scale, I suppose it's difficult to get all the needed shoots from a donor site. So maybe we also have to create some
nurseries.
Seagrass nurseries, yes.
Per, you wanted to add something?
Yeah, I think it's...
Can I come in?
Yes, Omar, please.
Oh, yes, Omar.
For us in West Africa, yeah, since this is the first time, we are starting the seagrass restoration, which is even undergoing right now here. So for us now, our decision makers, in fact, most of them are not even aware of the seagrass, the existence of seagrasses in the marine environment. So what we are trying to do is just trying to give them that awareness, so that when the decision makers, they are aware about the existence of the seagrasses, and then the important ecosystem services it is provided in the marine environment, which of course we are doing with our awareness campaign. So there and then we will start to buy them into try to integrate the seagrasses conservation into their various national or sectoral law. So for us at our department, the department where I am working, Department of Parks and Wildlife Management, now most of our decision makers now, they all know about the seagrasses. So we even we started integrating seagrasses in some of our marine protected areas management plan.
Okay, Per, you wanted to say something, and then we'll have to close and make some closing comments.
Yeah, I just want to follow up on what Peter was saying, which I think is the key here. At least with the methods we have in Europe, I don't think we can see restoration as the way to solve the environmental problem in the ocean. It's one of the small tools that we have, and it has to work in tandem with large-scale changes of the environment. So we have to work both on the local scale with the local problems of building marinas on top of seagrass beds, as well as nutrient pollution and climate problems, etc. It's only then that maybe restoration can play a role, as Siti was saying, to initiate, to speed up natural recovery. We can't solve eutrophication problem by planting eelgrass. It's the other way around. We have to solve that problem first and then help the recoveries. And I think that we all have to work on communicating that to policymakers and decision makers, because a lot of politicians seem to think we can just restore ourselves out of this problem. But unless you include working with nutrient problems as part of restoration sort of vocabulary, we have to tell them that we have to fix the environmental problems first. And then we can start to work on large scale. I think that is key.
Can I just add very, very quickly to that? So I think Per is you're definitely on the right track there. And if you look at like some of the new measures, and I'm thinking specifically about like blue carbon, like when you're talking about carbon offsets in seagrass meadows, it's actually not about the restoration of seagrass. It's actually about like the management measures to enhance the environment to then increase the capacity of the seagrass to naturally like sequester carbon. That's all I want to say. So if you want to look more into that, go read VM0033. But yeah, it's more about like what can you do in terms of improving water quality to then improve the conditions for seagrass growth, which is I think the way everything else should be going as well.
Thank you. I know we could all talk for hours about seagrass restoration, but we do need to close this panel discussion. Thank you to all the speakers and panelists. Thank you to everyone for joining us. We will have a few closing words from Cecilia Vatne, who is the project leader for the Norwegian Blue Forest Network, and she's going to talk a little bit about the seminar in Oslo tomorrow, which will be the third event of the Blue Forest Week. So go ahead, Cecilia.
Yes, let me just say thank you as well for everyone who joined today, both as a speaker and a participant. It's for me been a really great learning opportunity, and I think there's a lot of kind of food for thought and lessons learned that I hope we can really, make sure get out to the right people. And thank you, Karine, for moderating the session as well, of course. And I just wanted to say that tomorrow we will have our third and final Blue Forest Week event. It'll be live streamed seminar from the Norwegian Environment Agency Conference Center in Oslo. And the seminar aims to answer 3 questions. First, what are we doing to protect and restore blue forests in Norway? Second, what are the plans going forward? And third, is this enough? If not, what else should we do? Registration for in-person attendance is now closed. However, it is possible to watch online, but please note that the event will be in Norwegian. And my colleague Olivia will put a link to the live stream in the chat for those who want to watch that tomorrow. So that's it for me. Thank you again, everyone, for joining today, and I will turn it back to Karine.
Yeah, we'll stay online until 11:30, which is in 6 minutes. So if you have any more additional questions, feel free to ask. Some of our speakers, I think, are staying also. Carmen Santos brought up in the chat, or in the Q&A, if anyone has experience with, hi Carmen, is on the creation of seagrass nurseries for transplantation purposes, and whether it's possible to domesticate seagrasses in the near future. And unfortunately, Richard had to leave because I know in Project Seagrass that they do have seagrass nurseries and they're using seeds from those. I don't know if anybody else has any experience, and anyone from the audience who does, feel free to jump in here. I don't, by the way.
I think the Dutch actually have quite a lot of experience with this. I think Eduardo, maybe you know a bit better, like what the fieldwork company is doing. They presented something at the ISBW in Singapore about the seagrass nurseries that they are kind of creating for the different restoration projects in the Netherlands.
Yes,
or anyone in the audience? Yeah. Okay, go on.
Yeah, well, I don't know that much, but yes, I know that there is they are attempting to create these nurseries in the UK and also in the Netherlands by the Fieldwork Company. Yes, we have not attempted any of this. We have been kind of growing plants in the laboratory for experimental purposes, not for large-scale planting. To me, it seems like a really expensive way to restore. If you want to go large, I mean, if you want to restore a small area, perhaps, but if you want to go large, it seems a bit expensive. So we have not gone in this direction. But it could be a good solution if there is no donor planting material in a site, for example. If you don't have other choice, yeah, okay, that could be. It will be more expensive, but maybe it's the last chance you have, so why not?
Can I comment? In general, I think it's sort of a step in the wrong direction in the sense that it's so hard to make seagrass grow. So if you manage, you might as well put it where you want it to grow. So instead of planting it in a greenhouse, you might as well plant it in the field somewhere that you want to restore. If you need to take it from somewhere initially. And then if that succeeds, then you can use that as donor material. That will be your nursery. I think that makes more sense in my mind because it's notoriously difficult to grow at least eelgrass in the laboratory. The light demands are huge. And I mean, all aquarists are asking me regularly, how do you do it? And Eduardo, it's possible, but it's very difficult. So I don't know, Carmen, what species you are working with, but it's always easier outside, I would say. and why not put it in the field where you want it to grow directly and have that as a nursery?
Yeah, so thank you very much, the three of you, for your view on this. Yeah, well, basically I work with Sostra Marina Simorosi Meadows and Sostra Nolti, and we have a kind of natural nursery that we are using, but it was not something that we created. It's a semi-natural pond with seagrasses growing naturally there. And we are using it for transplanting purposes. But my question is more, I wrote like near future, but maybe we should think even in a longer time framework, because it's true that normally within our generation, right? But if we think about domestication of crop plants, it took many centuries, I would say, right? By selection of the crops and the species, and then trying to understand the plant's needs, and also from the genetic point of view. And my question was more about should we try to domesticate seagrasses, even if we know that it will take decades or even centuries? Because of course, we are now thinking about to solve the problems of nowadays, but if we think in the future, probably the population is increasing, and we may need also seagrass in centuries, right? So it's more philosophical, I would say, question.
Yeah, that's a very good point. Maybe it could be a possibility, but what I see is that seagrass doesn't have an economic purpose. So we are not going to make much money with it. We are not going to eat it. So with crops, it makes sense because it's for living and it's an economic. So I'm not sure if there's going to be investment in this, but definitely will be interesting to adapt the genetics for specific sites so it can grow better. That could be interesting. Make better, stronger crops of seagrass could be interesting, but I don't see the economic kind of behind supporting that, but maybe.
If I can come in, it's another aspect when we domesticate crops. It's for one particular purpose, to grow quickly and produce a lot of whatever we want to eat from the crop. Here we want high diversity, maybe, which sort of goes against domestication. So it's I think there might, but it's an interesting idea that you are bringing out. There might still be a need to raise climate tolerant, genotypes, for examples, that can take heat waves or lower salinity or something like that. So there might be sort of still a purpose for that type of, I wouldn't call it domestication, but something in that line, that you want a specific type of breed. There is some research going out in our group about dealing with the Baltic situation with warmer seas and lower salinity, to look into that. But yes, I think the idea of having maybe areas dedicated to be donor sites for that purpose, that is not a bad one. But our experience is, if you sort of just thinning a meadow, at least for eelgrass, they grow so quickly vegetatively, you are not having a negative impact. You're just bringing in more light, so they grow faster, and then they are replenished, the lost branches, so to speak. So harvesting shoots, even for planting them, is not something that kills or necessarily negative for the meadow, if you do it in the right amount. Thanks.
Can I say something, or is it already time's up?
Oh, go ahead. We can close after you.
Okay.
Siti.
So I think this is a very interesting discussion, and I think that if we do want to pursue this is something we can learn from our coral reef colleagues, because they've done a lot of coral nurseries, right? And they've dealt with all those problems of like what's the opposite of genetic diversity? Lack of genetic diversity, and also doing the selection for strains or for certain corals that have heat tolerance and things like that. So I feel like there are lessons that can be learned from other, I guess, marine analogs or marine habitats, and maybe, and I think this is just again asking for too much, but then instead of us doing a bit of navel gazing and seeing what can we do for seagrass, blah blah blah, and only involving the seagrass people, I think there is a need to branch out and look at it at a whole marine system point of view as well, because there's a lot of lessons that can be learned there.
Yep, absolutely. I think that's a good note to end on, that we can't consider seagrass in isolation. We have to consider it in a seascape, and all the other habitats that are next to it or around it or even far from it. So I think we'll end there. Thank you to everyone who joined. Thanks, Carmen, for joining us. And thank you to everyone who asked questions. And thank you again. Bye, everyone.
Bye.